So today, lesson B3, proof of the Pythagorean theorem. What you want to be able to think about the I can statement is that I can explain and use the Pythagorean theorem. So far the patterns we've discovered in our previous lessons is a famous theorem called named after the Greek mathematician Pythagoras. A theorem is just a general mathematical statement that has been proven true. The Pythagorean theorem is one of the most famous theorems in mathematics. There are over 300 different proofs that have been given for the Pythagorean theorem. One of the proofs is based on the geometric argument that we're going to look at today in this problem. So today you will need the scissors again. You will be cutting out the different sized puzzle pieces again, and then part of your homework is to finish that. So what is the Pythagorean theorem? So the Pythagorean theorem is just that. It's a general math statement and that has been proven true. And when we think of that, because it was proven true, you want to make sure you're writing this in your notes. The theorem comes out to be a squared, so a side squared plus another side squared equals, or leg squared, equals the hypotenuse squared. So what is the rule that we wrote in the previous? So today, when we are looking at this, in the previous lesson, what we said was this, that as we take a look, we said it is the area of the leg plus the area of the second leg is equal to the area of our hypotenuse. Now, when we're talking about area of the leg, we're talking about area of the leg, and we're talking about that square. So that first square, the second square off the leg, and then the hypotenuse. What does it mean? It means that as we are looking at this, that we can take the side leg, and if we know the side length, we can take that and square it, plus the side of a leg B and square it, is going to be equal to the hypotenuse side and squaring that. Make sure you have this in your notes. If you need to pause it to make sure everyone has it written down, please do so. Why is this proof of this theorem, if we are looking at this? Why prove it? It says we have seen many examples of right triangles that satisfy the Pythagorean theorem. While these examples are convincing, we can never be sure that a theorem works for all right triangles. To be sure, we need a mathematical proof that uses reasoning to show a conjecture. For example, if we go on a trip to Seattle and it rains for 4 days, that I'm there, can I say that it always rains in Seattle? So if we are thinking about that, we should say no, we don't think so. And it rained every day that I was there. It was never sunny. So if we are thinking about this, what do we know as we are looking at this? And this is what I want you to write down in your notes. We can't say, if we are looking at that, we cannot say that since it rained every day, it'll never be sunny. The same is true in math. When we've looked at many right triangles and they've all worked, does that mean it works for everyone? Maybe, but we need to prove how it works, and that's what we are going to do today. Right now, if the sub did not hand out to you at the beginning of class, you're going to have a pink sheet. And what you are going to do is you're going to cut out the squares. It has 2 puzzle pieces on that pink sheet, and we're going to do this together in class. And what I want for you to do is the largest square is going to be labeled with C going around those. The middle square is going to be B going around the sides, and the small one is going to be A, and you should be able to write those inside on those squares. Then you will also label your triangles. When you're labeling the triangles, the shortest side is A, the middle side, the other leg is B, and the hypotenuse will be a C. And you are going to cut all of these out so that your pieces look like this. So you'll pause the video right now while everyone is getting theirs cut out on the pink sheet. And actually, I think we are this year doing the green sheet first. So yours will be on the green sheet that is labeled A. Okay. So it says, study the pieces of the three square pieces. How do the lengths of the squares compare to the lengths of the sides? So if we are looking at that, what do we know about the lengths of the sides compared to the lengths of the squares? Each side of the triangle is equal to the length of one of the three squares. So if I look at this A is going to be exactly the same length as here. This side B should be the same length as here. And side C, if I match it up, will be the same side here. The first thing you're asked to do is to arrange the 11 puzzle pieces to get them to fit in these two frames. My hint is the two smaller squares go together and the big one is by itself. You might have things turned, so pause the video again and try and arrange these. What it then asks you is, what conclusion can you draw? So what we might do is have the document camera on and just switch between the video right now, which is being paused, and the document camera so that you can see what some students did. And as you look at that, the conclusion that we want to make is that the sum of the areas of the two smaller squares is equal to the larger one. And when you arranged yours, I should have seen something like, and you're going to see it in just a minute in this picture that I'm going to show you, that when I look at yours, I should have seen like maybe the small square, something like this, and the middle square. So this is my A, this is my B, and then I might have two triangles like this. In the bigger other square, the puzzle pieces, I might have something that goes like this. And my drawing isn't going to be great, but I should in each of these have 4 triangles, and this is the side C. So this is kind of what yours should look like. And if you need to pause it and make sure everyone kind of gets theirs to look like this, do so, because this is really important that you see where these squares are coming from. Now, the question says, what conclusion can be reached in part 2, and what does it mean in terms of side lengths? And this is what I want you to write down. In terms of side lengths, the sum of the square length of the legs of the right triangle is equal to the length of the hypotenuse. And some people might be going, I don't get this, this doesn't make sense. Remember, as we started the last unit, you were confused also. But what I want you to think about is writing this down, that you started that first puzzle piece with a squared plus b squared, those are my 2 squares, plus 4 triangles. Those 4 triangles were also in the c squared plus 4 triangles. Now, just thinking about equations, if I take away the 4 triangles on one side and I subtract them on the other side, what am I left with? I am left with a squared plus b squared equals c squared. Now, we are going to look at the summary of this investigation. So you're going to copy in these sections what we are looking at. We're going to copy those down. So just take a look at each section as I show that. If you need to take some time to pause the video after you have all 3 up, please do so. So in the first one, the first conclusion, look at the relationship between the squares and the triangles. When we look at this relationship, this is our A, this was side A. This is our B, this is our right angle. This was side C. So we know those sides match up. That was the first thing we might have noticed. So you're going to draw that picture. The next thing, in our puzzle pieces, and you might have arranged yours similar to this, or you might have had it a little differently. One possible way to arrange them is this. So kind of like how I had, but drawn a little differently. And the last thing that I want you to do is to write this down, and we're going to put observations. So this is number 3. So this was 1, 2, and then 3. And pause the video so that you can write all of these down. The areas of the frames are equal. We know this frame equals this one. Each frame contains the identical 4 right triangles. The shapes fit exactly in the frame by matching A plus B dimensions. The 4 right triangles, like we said, were removed from each side. And what we are left with is that the sum of the areas of the square of one frame is equal to the sum of the areas of the other frame. Thus, the A squared plus B squared equals C squared. And again, pause the video so that everyone can write this down. So what can we do to summarize this proof? It says in this lesson and previous, we've explored the Pythagorean theorem for a relationship with the side lengths of right triangles. State the theorem for any right triangle A, B, and C. And it should be that A squared plus B squared is equal to C squared. This is what you will use to start all of your assignments today. You must have this down. And then the key thing is, remember, these are the legs. These two are your shorter sides. This is the hypotenuse. When we are looking at that hypotenuse, this is the longest side. So this must be the biggest number here, okay? This must be the biggest number when you look at yours, okay? So when you're plugging them in, remember, these two will be your 2 smaller numbers. Now, we need to practice because your homework will not only be cutting out those triangles, and the scissors will be provided, but you need to solve this. So what am I looking for in your homework? I want you to start with the theorem. A squared plus B squared equals C squared. Next thing, go around the picture and put A, B, C. You can do the same thing for this one right now. A, B, C. Does it matter which one is A and B? No. We are then going to substitute in 2 squared plus 6 squared equals C squared. Square the numbers. You have these memorized. 4 plus 36 equals C squared. At this point, many people like to put the variable first. I do. C squared equals 40. We are not done with the problem. It does not say find the area of this square, which is 40. It says find the side length. So remember, this is area of the square. So when we thought about our homework, and we did this the last unit, if the area of the square, what is the side length? Square root 40. And we are going to leave our answer as square root 40. Okay? Now, you should have your calculators and put that in. We do know that it's between 6 and 7. And as you put that in your calculator, we'd put 6.32 units. Let's try the next one. Again, please start the problem with writing your theorem. A squared plus B squared equals C squared. We've already identified the sides, so A is 4 squared plus B stays by itself. We don't know that. That's our question mark. Equals C squared. And C in this case should be 7. 4 squared. This is the work I must see. 16 plus B squared. Don't skip steps today. Equals 49. We want to get B squared by itself, so we are going to subtract 16. Show this work. This gives us 0, so we're left with B squared. And we are going to take 49 minus 16, and it leaves us with 33. Again, this is the area of the square. Keep that in mind. What is the side length? That's what B is. B is the side length. The side length equals square root 33 units. So up here when we write our answer, we're going to put the square root of 33 units, which is approximately, in this case, between 5 and 6, 5.74 units. Now the homework would possibly ask you to round it to the nearest number. So one of the first things you're going to do is you're going to get this white sheet, and you need to cut out the pink and the blue triangles and squares, and your homework assignment is to get them taped in. Look at your notes for how they need to look. Next thing, you are writing and doing the 3 questions here. And this question, first thing again, what you want to do is label the sides. So make sure you label the sides. What do I mean by label the sides? Go around and put the A, B, and C. When you do that in this, so 5 and then 6, this one you have to try to solve both of these. So you have to do 2 problems for this one. And my hint is, when you look at this, go around and put your A, your B, your C. This might be A again, this is your B, and this is your C. Make sure you show all your work, check the answers, and do the puzzle pieces.